Hi, this is Greg Lazarchek from Lazar Scientific, and next to me is
Michael Zelna from Lazar Scientific.
So today we're going to give you a brief comparison of the Seta Pensky-Marten D93 flashpoint and the Setaflash
Series 8 small scale flashpoint.
We're going to review the methods of each instrument and their applications. So we're going to start off with the Pensky-Marten D93. It's the ASTM D93 flashpoint. There's also IP methods that it does, but they're basically all the same. And since we're in the United States and North America, we'll talk about the ASTM methods. Flashpoint by Pensky-Marten, closed cup tester, has three procedures in it. It has procedure A, B, and C, and they're all a little bit different as far as their heating rate, stirring rates, and what they are used for.
Yes, sir.
The Setaflash Series 8.
Setaflash Series 8 is a little more complicated. We have four different methods here. We have the ASTM D93, which is our go, no-go test. We have our D7236, which is the ramp method, our D3278, and our D8174, which is for wastewater products.
So the procedure A is used for distillate fuels such as diesel, biodiesel blends, kerosene, heating oil, turbine fuels, lubricating oils, and other homogeneous petroleum products. As you can see on the Pensky-Marten, all the methods use stirring, and they all have a very non-equilibrium method. They were actually using a heating rate on them. It's not a equilibrium like some of the no-go tests on that. Procedure B is a procedure that a lot of people should be using, but over the years they haven't used it. It is for stuff that has a much heavier viscosity, tends to form hot pockets and get superheating. So anything like residual fuel oil, cutback residue, asphalts, lubricating oils that are heavy, petroleum mixtures that have solids in it that can separate out, and actually use waste oil sometimes too, or tend to have a film on top. Having that stirring at a higher stirring rate, which method B does, and a lower heating rate gives you much more consistent results. Because in method A, we're actually heating 4 to 5 degrees per minute, but we also have a stirring rate between 90 and 120 RPMs per minute. So in method B, we actually take that stirring rate and double that, but we cut the heating in half. So what you do is you get a much more even heat. You don't get the hot spots, and for samples that need that, you'll get very consistent results. Procedure C is the newest method, and that is for a B100 for biodiesel. In the method, the precision statement covers between 60 and 190 degrees C by automated flashpoint that you're allowed to use that for the B100. It can do a wider test range for that, but that was really made just for the B100, and it is a special method. You should be not using method C for anything else except for B100.
So what range can we run that method A and B over, though? I think that's what people are really going to want to know.
So, people say, well, what's the starting temperature? Well, really, you're looking at, it depends on your ambient temperature where you're at. So it's probably ambient plus about 15 degrees above that, but but it can go all the way up to 300 degrees C. So you can run a very, very hot sample, almost like a lubricating oil in there, even though most people will probably run that by the Cleveland flashpoint.
Yes.
So it's a very, very wide temperature range, but where it's not good is when you're getting down near flammability. When you're getting around 100 degrees, that 140 and above, yes, but really 100 and above Fahrenheit, right around 40 and above C is where this really shines on that one.
So what if I want to do something below that?
You really shouldn't be using this method.
Okay.
Yeah.
I guess that's a good segue into what I'm here to present today then, because this is the great solution for subambient testing. The Series 8 actually goes all the way down to minus 30 C and all the way up to 300 degrees C. That's two different analyzers there. The ActiveCool here we have on the bench. It's minus 30 to 135, so you can cover those subambient flashpoint measurements. You don't need any additional chillers, cooling water, or anything like that. This instrument itself, as it sits here on the bench, will go all the way down to minus 30.
Now that's a change, isn't it?
That's an improvement over the previous model, the 2020 model now. A couple big improvements, but the biggest one is we're done with chillers, we're done with the cooling water, all internal, minus 30.
Okay, great.
You can use this for a wide range of liquids. You're not just limited to the petroleum products and biodiesels like we talked about with the Pensky-Marten. You can do all those same things, but we can also do paints, coatings such as varnishes, lacquers, enamels, things like that. Great for the paint industry. Also flammable liquid waste products. The real big advantage here too is you're looking at 2 or 4 mils for your sample size. If you have a very expensive product that you need to measure the flammability of, we're only looking at 2 mils versus
75 for the Pensky-Marten. Big difference.
big difference there.
Yeah.
No stirring on this, and the question always comes up, well, how do you keep it evenly heating if it isn't being stirred? Well, such a small sample size in such a wide cup, we get a very thin layer on the bottom, and that makes it heat much more evenly and doesn't require the stirring like the Pensky-Marten does. This one is also available for people with corrosive samples with a corrosion-resistant cup. So the cup has a stainless steel liner to prevent attack from corrosive samples versus the Pensky-Marten, which is a great upgrade.
Yeah, and anybody who's doing wastewater, we would recommend that you do that.
Yeah, it really is a must.
Because
on
if not,
anything like that.
after a few years, you'll replace the cup if you don't.
Oh yeah, anything outside of 4 to 10 pH, you're going to just destroy that aluminum cup almost instantly.
And if you put that in a Pensky-Marten, it would just sit there and eat up your impeller, and we'd have to rebuild all that. So again, if you're doing that, the Series 8 is the way to go.
Yes, sir.
If you're doing anything like essential oils, perfumes, very expensive samples, where you're making a new pilot plant run, well, you might have to run an extra 1 or 2 days just to get enough material to fill this cup up at 75 ml. Here you don't, so it actually reduces your cost of getting a product to market, and that's really an excellent choice for those people. People in the flavor and fragrances industry use this. Automotive paint industry use this because they have very, very, very low flash points, and this is the way to go.
And it's a lot safer too. We're only dealing with 2 or 4 mils of sample over 75.
Very good point.
Yeah.
So I hope you've learned something. If you have any questions, you can get in touch with us through our website. But thank you for watching our video, and we will have a little bit more.
Yeah, stay tuned. We're going to be putting out more videos. Flashpoint Friday is going to become a thing here.
And the next video we'll actually go over the operations of these instruments.
Get a little more in depth on
And-
actually using them.
I mean, we'll get our hands dirty.
I hope not, but we'll see.
All right. Well, thank you for watching. We really appreciate it. Stay safe and take care.